Welcome to the celebrated High Achievers Mentorship Program, CHAMP. We are bringing academic dreams to reality. So in this video, we'll be treating hydrostatics. Now, hydrostatics is a special topic of interest as we've received a lot of messages on treating this topic. So because of the time factor, I will just give the all the cases that are in hydrostatics, every form of questions that can be asked, and going through all the past questions and make sure that a type of question is given for every forms of question that can be asked. So we'll be solving a lot of questions. So just do well to sit back, get a book and pen, try to follow on, and don't forget to like, share, and subscribe on the channel. Yeah, let's move on now. Hydrostatics. So we'll be dealing with density, upthrust, and all of that. Let's start. What's the keyword? We have density. What's the formula for density? Density is the what? Is the mass acting per unit volume. So density is what? Mass over volume. Density is what? Mass over volume. Yes, let me stay here a bit. They do ask some questions on this. Now, if for instance you are asked to, you are given the so if for instance you are fine, one thing you must note about this formula is that m is equals to what? Density is rho v. Density mass is equals to density times volume. Then another thing, so mass is actually constant. Mass is constant. Please take note of that. So you can stylishly have rho 1 v1 is equals to rho 2 v2. Please, this rho is not the same thing as pressure. Is your what? Is your density. So you can be given the density and volume of two different substances, and you'll be asked to find, maybe, yes, we'll take questions like that. So yes, and sometimes they can ask you to find the density of a mixture. They will give you, how do you find the density of a mixture? First of all, get the mass, the addition of the mass over what? The volume of the mass. Yes, that's very simple. Then you can be asked to find the change in volume. Maybe they said ice changes to water or water changes to ice. Yes, I'm staying here because there are some crucial questions that can be asked on this place. So I will stay here a bit before I launch deep into stoichiometry, to hydrostatics itself. Yes, if they say water is changed to ice, so this is it. What's the formula for density? Density is equal to what? Mass over volume. Then I ask you for your change in volume. Yes, so you just say, volume is what? Mass over density. So you get the volume of water, you get the volume of ice, then you do what? To subtract. Let's take some questions on that now. Yes, I have a question here. I think it was asked in 1994. The density of water is 1 gram per centimeter cube, while the height of ice is 0.9 gram per centimeter cube. Calculate the change in volume when 90 gram of ice is melted, or is melted. So how do you do it? I told you that you just do what? Get your volume. Volume is equals to what? Mass over density. So get the volume of water. You've been given the what? The mass. I told you the mass is always constant. Mass is 90 gram. So it's 90 gram for ice. It's also what? 90 gram for water. So what's the volume of your volume of water? Is what? Mass over density. This is what I proved here. I just made it the subject of the formula from this place. So what's your mass? Mass is constant. 90 over what's the volume, and the density of water is what? 1 gram per centimeter cube. It can also be equals to what? 1000 kilogram per centimeter cube. But here you have gram. So you don't need to convert. It's in gram already. So yes, that's what? 90 centimeter cube. The same thing for volume of ice. What's the volume of ice? Mass over density. What's mass? Always constant. Let me write the formula. Mass over density. Mass is always constant. Then ice is what? 0.9. That's what? 100 centimeter cube. They said find the change in volume when 90 gram of ice is melted. So that means you have ice before. So that will be what? Volume of ice. What you have before minus what? Volume of water. So that's the change in volume. So that's 100 minus what? Minus 90 is equals to what? 10 centimeter cube. Yes, there's also a jam pass question on this, so you'll be the one to try this next one. Let me just write it down. So this is a question now. Calculate the change in volume of 50 grams of ice when it is melted to water. You have the density of your water, you have the density of your ice. It's just the same approach. Can you just pause it and try it on your own now? Yes, I'm sure you've done that now. So yes, let's move on now. It said calculate the change in volume of water. Get the volume of ice, or the volume of water first. Anyone. Volume of ice is what? Density over mass, right? What's density? I'm sorry. Density is mass over volume. So it should be mass over density. I'm sorry. So this is the formula. What's your mass? Mass is 50 gram. Always constant. What's your density? 1. So you have 50. So what's volume of water? Volume of water is mass over density. So the mass is constant. It's the same here and here. So that's what? 50 over, what's density? 0.9. Yes. So let's try to divide. So I'm coming. Let me press it here. So this is what? 55.5. Oh, there is a mistake. This is the density of ice. So let me just change this. Volume of ice. This is the density of water. Volume of water. Yeah. So just calculate the change in volume. Ice minus water. So that's what? 55.5 minus what? Minus 50. So that's what? 5.5 centimeter cube. I guess you can solve any question on change the volume now. Yes, another type of question you can be asked is when your mass is constant. And I told you that when your mass is constant, I've told you already, density is equals to what? Mass over volume. So you can have rho 1 v1 is equals to what? Rho 2 v2. Let me just pick a past question that was asked on that, then you practice. So 1 or 2 questions on that now. Let's go. They said this is 2006. What volume of alcohol with a density of 8.4 times 10 raised to power, please, I'm coming, I can't see this very well. Yes, 8.4 times 10 raised to power 2 kilogram per meter cube will have the same mass as 4.2 meter cube of petrol, whose density is 7.2 times 10 raised to power 2 kilogram per meter cube. Yeah, so let's solve it now. They said the volume of alcohol, that's what you are looking for. Density of alcohol, that's what? 8.4 times 10 raised to power 2 kilogram per meter cube. Then they said we'll have the same mass. Yes, mass is the same as 4.2 meter cube of petrol. So volume of petrol is what? 4.2 meter cube. Whose density is what? So density of petrol is what? 7.2 times 10 raised to power 2 kilogram per meter cube. Do you get it now? So I told you that mass is constant. So you have rho 1 v1, that of alcohol, is equals to what? Rho 2 v2, that of petrol. So slot in your value. What's the density of alcohol? 8.4 times 10 raised to power 2. What's the volume of alcohol? This is it. What's the density of petrol? 7.2 times 10 raised to power 2. What's the volume of petrol? 4.2. So you can cut, or you can press it straight, anyone. So volume of alcohol is equals to 7.2 times 10 raised to power 2 over 2 times 10 raised to power 2. So you have what? 3.6 meter cube. I guess it's very simple now. So you can just play back and try to solve again. Because this one is very simple, I won't like to waste much time on that. So with this knowledge, there should be no question like this that we won't be able to solve. Let me go to another type of question. Yes, let me think. Now, there are some questions where they will ask you to find the density of mixtures. I talked on that already. If they ask you to find the density of a mixture, what's the formula for density? Density is what? Mass over volume. But this is a mixture. It's more than one compound. So you find the mass of both substance, M1 plus M2 over what? Volume of both substance. If it is 3, it will be plus M3, V1 plus V2. So this is what? For the density of mixtures. Density of what? Mixtures. So yes, let's take a question on that now. So we have okay, JAM 1990. JAM 1990, they asked this. 40 meter cube of liquid is mixed with 60 meter cube of another liquid of liquid P is mixed with 60 meter cube of another liquid Q. If the density of P and Q are 1 kilogram per meter cube and 1.6 kilogram per meter cube, what is the density of the mixture? Yeah, let's move on now. So we have volume. Okay, yes, let's write our parameter. They give you the volume of P already. Volume of P, that's what 40 meter cube. They give you the volume of Q. Volume of Q, that's what 60 meter cube. Density of P, that's what 1 kilogram per meter cube. Then the density of Q, that's what 1.6 kilogram per meter cube. They now said you should find the density of the mixture. Now it will be very foolish for you to add this density of both of them and say 1 plus 1.6, 2.6. You'll be wrong. Although you see that in your option. But that's very wrong. So what's the formula? Density is equals to what? The sum of the masses over what? The volume. So you get the masses first. So M1 is what? What's the formula for mass? Rho V. From, density is equals to what? Mass over volume. So if I cross multiply, mass is what? Density times volume. So what's the mass of the first one? Mass of the first one is what? 1 times volume of P. That's 40. So the mass of the first one is what? 40 kilogram. Reason because this is in kilogram. Yes, M2. M2 is also what? Rho V, but 2 is what? Q. So we have, what's the density of Q? That's what? 1.6. What's the volume of Q? That's what? 60. So you have 1.6 times 60. That will give you what? 96 kilogram. So they said, what's the density of the mixture? Density of the mixture is what? M1 plus M2, the sum of the masses over the what? The sum of the volume. So what's the sum of the masses? 40 plus 96 over, what's the volume? Volume is what? 40 plus 60. So you have 136 over 100. So that's what? 1.36 kilogram per meter cube. So this is the density of the mixture. 1.36 kilogram per meter cube. Yes, with my answer here, that's option what? That's option D. Yeah. So they can ask. Let me see if I can be able to see another question like this so that you can try it out. But wait, because of time, let's just go into the deep part. But if you asked questions on the preliminary aspect, that this with the formula of density is equals to mass over volume, I don't think you should have problem now. You know that your mass is always constant, so you can have rho 1 v1 is equals to rho 2 v2. I'm just trying to make a recap. Then you can also have what? For density of mixtures, m1 plus m2 over what? V1 plus v2. Then you can also have change in volume, the volume of the first one, which is what? Which is mass over density minus the volume of the second one. Yeah, so it's very simple. Let's move on now. So now the basis of the calculation of hydrostatics is actually based on Archimedes principle. So what does Archimedes principle say? I'm coming. So yes, Archimedes principle. Archimedes principle states that when the body is partially or totally immersed in a fluid, it experiences what? An upthrust. So this is it. This is a liquid. This is a liquid. You immerse something in it, maybe a bath, and this bath is weighty. So once you immerse it in it, or anything that is heavy, this thing will experience a what? An upthrust. A upthrust that will push it up. That's why they can ask, what's the direction of your upthrust? Up. What's the direction of your weight? Down. Never forget that. Now it experiences an upthrust which pushes it up, and this is the reason why when you are fetching water, when the water is usually heavier when it is outside the water than when it is inside the water, because when it is inside the water there will be an upthrust that will be supporting the weight of that body. So yes, the formula for upthrust is actually, upthrust is equals to the weight in air, the weight of this body in air, which will be heavier, minus the weight of this body in what? Inside the liquid. So the upthrust of a liquid, the upthrust in a liquid is weight in air minus weight in liquid. So if I want to find the upthrust of water, upthrust of an object in water, so that will be what? Weight in air minus weight in water. Upthrust of an object in petrol, that will be what? Weight in air minus weight in petrol. And all of that. I hope you get it now. So that's just that. That's just that. That's upthrust. That's what an upthrust is. That's what an upthrust is. Yeah, so the upthrust. So according to Archimedes' principle told us that it will experience an upthrust which is equals to the what? The weight of fluid displaced. So this upthrust is usually equals to the weight of the weight of the fluid, the weight of the liquid that this body displays, the weight of the liquid that this body displays. So yes, let's take note of that. So we'll take questions now, but before then, let me just quickly give us the formulas. Yes, let me talk on relative density, so that after now we'll just take questions. Yes, but before I talk on relative density, let me just prove this one. They said it's equals to what? Weight of fluid displaced. Upthrust is equals to weight of fluid displaced. So what's the formula for weight? Mg, right? So your M is what? Mass of fluid displaced times what? Times acceleration due to gravity. Then upthrust is what? What's the formula for mass? Density is equals to mass over volume. Mass is what? Density times volume. So you have rho V times what? Times G. So this is it. Density times what? Times volume times G. Now you must be very careful here. You must be very careful here. This is your density. Is the what? The density of that liquid. The density of that liquid. Then this your volume is the what? The volume of your object. The volume of the object that you are immersing in the liquid. Please take note of it. This density is not the density of the object. It's the density of that liquid. How dense that liquid is. That will determine the upthrust. The same thing for this V. The volume of your objects. Yes. The volume. The volume. Yes. This is about how you used to know it. This is P. This is like P. So Premier League. If you're a football fan, you'll be familiar with that and all of that. So let's move on. So you have rho VG. So yes, let's take note of that. Then okay, I said I want to talk on relative density. Now we have the relative density of solids. Now, what's the meaning of relative? Like we are comparing the density of something to each other. So the relative density of solid is just density of substance over what? Over density of equal volume of water. Equal volume of water is also equals to what? It's also equals to mass of substance over what? Mass of equal volume of water. It's also equals to what? Weight. Mass is like the weight. The only difference is the acceleration due to gravity. Mass of substance over weight of substance over weight of equal volume of water. Then it can also be equals to what? The weight of substance in the air, the weight in the air over what? The upthrust in the water, or the upthrust in liquid. No, it's always against water. Always against water. Yes. Now you don't need to. You can just cram it, but it's very easy to cram. Relative density is what? Density over density. Density of substance over density of water. These two are actually the same. The mass of the substance over mass of equal volume of water. Then it's the same thing as what? Weight of substance over. Now this weight of equal volume of water is the same thing as a what? Upthrust. If you remember Archimedes' principle, he said upthrust is the same thing is equals to the what? The weight of fluid displaced. He said it experiences an upthrust which is equals to the weight of fluid displaced. So this place, I'm just changing this last part, weight of liquid displaced. So I just change it to what? Upthrust. So upthrust is the same thing as your weight of liquid. So these four formulas are actually the same thing. Density, the mass and weight is the same thing. Then for the fourth formula, I just changed this to upthrust. So what does that mean? What does that mean? What's the formula for upthrust? What's the formula for upthrust? You know, upthrust is what? Weight in air minus what? Weight in a liquid. So I can say the relative density of a liquid, relative density of a solid, I mean, is what? The weight of that substance in air over the upthrust, which is what? Weight in air minus weight in liquid. So this is the relative formula for the relative density of a solid. This is one of the formulas. Yes. So this is just the fourth formula written again. Weight in air right? What is the upthrust? Weight in air minus what? Weight in liquid. Weight in air minus weight in liquid. So if they give you a question and they say a substance weigh 10 Newton in air and then 3 Newton in water. Yes, what is the upthrust in water? Yes, what is the upthrust of that on that object? That's what 10 minus 3. That's 7 Newton. Anyhow, yeah. Let's move on now. Yes, let me talk on the relative density of liquid. Then we can start taking as many questions as we can. Now, relative density of liquid is what? You just pick an object, put the object in that liquid. So the upthrust that is experienced by that object in that liquid over the upthrust of that object in water. So upthrust of object in liquid over upthrust of object in water. Let me turn this into a formula. Relative density of liquid, that's what? Upthrust of object in liquid, that's what? Weight in air minus weight in that liquid. You know, this upthrust in liquid. But for that relative density of solid, you just weight in air over upthrust. But this one is upthrust over upthrust. So weight in air minus weight in liquid over object in water, weight in air minus weight in water. So this is the formula for the relative density of liquid. Liquid is in contrast to that of solid. Relative density in solid is what? Weight in air, only weight in air over weight in air minus weight in water. So mark the difference. Mark the difference. This one is upthrust over upthrust. This one is what? Weight over upthrust. Yeah. Then let me just give one more formula for the relative density of liquid. It's the same thing as what? The volume. You know, upthrust is directly proportional to the volume of object, rho Vg. So the volume of object or the volume of liquid displaced by the object over the volume of water displaced by the object. So take note of that. Yeah. So let's take questions now. Yeah, we'll be taking a whole lot of questions until you get it very well. Just follow through and be ready to practice questions. Yes, I have a question here. 1990. An object weighs 10 Newton in air and 7 Newton in water. What is the weight? So what is the weight when immersed in a liquid of relative density 1.5? So this is from 1990. So yes, what's this? They said the relative density of what? A liquid. What's the formula for relative density of liquid? Upthrust in liquid over what? Upthrust in water. What's the formula for upthrust in liquid? Weight in air minus what? Weight in that liquid over upthrust in water, weight in air minus weight in water. What's the relative density of the liquid? 1.5. What's the weight in air? 10 Newton. What's the weight in that liquid? That's what you are looking for. What's the weight when immersed in the liquid? Over what's the weight in air? 10. What's the weight in water? 7. Are you getting it? So you have 1.5 is equals to 10 minus weight in liquid over 10 minus 7, that's what? 3. So cross multiply. 4.5 is equals to 10 minus weight in liquid. Weight in liquid is what? 10 minus 4.5. Weight in liquid is what? 5.5 Newton. Yes. So that's my answer for that. I guess you get it. If you don't get it, just play back and try again. We'll be trying another one now. Yes, we have another question here. Yes, this 2000. A solid weighs 5 Newton in air, 4.2 Newton in water, and 4.4 Newton in liquid. Why? They said calculate the relative density of Y. The relative density of Y. What's the formula for relative density? Now they said that it is what? Is a liquid. So what's the formula for the relative density of liquid? Upthrust in liquid over what? Upthrust in water. What's upthrust in liquid? Weight in air minus weight in liquid over weight in air minus weight in water. What is it? We are looking for relative density. That's what. What is weight in air? 5 Newton. What's weight in liquid? 4.4. What's weight in air? 5. What's weight in water? 4.2. So that's what? 5 minus 4.4. That's 0.6 over 5 minus 4.2, 0.8. So if you do it, that's what? 3 over 4. So the relative density is what? 3 over 4. Another question now. Let's go now. So we have another question, JAM 1991. The mass of a stone. Yeah, they give you as mass. It's 15 gram when immersed in water, and 10 gram when completely immersed in a liquid of relative density 2.0. So they're giving you the relative density of that liquid 2.0. What is the mass of the stone in air? What is the mass of the stone in air? Are you following? So yes, let's move. What's the formula for relative density of liquid? Liquid of relative density. That's what weight in air minus weight in that liquid over weight in air minus weight in water. Now weight and mass, they are what? They are related. Is only the only difference is what? Acceleration due to gravity. So the acceleration due to gravity can just cancel out. So your formula is also the same thing as what? Mass in air minus mass in liquid over mass in air minus mass in water. Do you get it now? Yes. What's the formula for relative density? 2.0. Oh, this weight in water. Yes. You know, water is always the reference point. It's the one down. Yes. What's the mass in air? That's what I asked to find. Find the mass of the stone in air. Minus what's the mass in liquid? That's what? 10. Mass in air, that's what you are looking for. What's mass in water? 15 gram when immersed in water. So let's cross multiply 2.0 into brackets MA minus 15 is equals to MA minus 10. 2 times MA, 2 MA. 2 times 15, that's what? 30 MA minus 10. 2 MA, bring this one here, minus MA is equals to minus 10 plus 30. 2 MA minus MA, that's what? MA minus 10 plus 30, that's what? 20. You get it now. So your mass in here is what? 20 gram. Yes. Here with me is in option C. Yeah, that's what they got. Let's move on now. Yeah, I trust you are getting it now. Yes, it's getting very, very simple. Yes, this type of questions is common. So I have a lot of questions here. So I will just be taking, like, let me take 10 more. Any 10 random. Yeah, I have one here, JAM 1994. This one is somehow complex, so it will make it interesting. The mass of a specific gravity bottle. The mass of a specific gravity bottle is what? Is 15.2 gram when it is empty. This is a sweet question. Yeah, it is 24.8 gram when filled with kerosene and 27.2 gram when filled with distilled water. Then they said calculate the relative density of kerosene. It's that simple. It's very simple. What's the formula for relative density of kerosene? Yes, kerosene is a liquid. So that's what? Weight in air or mass in air. Yes, you have mass here. So you can just use it straight. Mass in air minus what? Mass in that liquid. Now our liquid here is what? Kerosene. Mass in air minus mass in kerosene over mass in air minus what? Mass in water. Now, yes, what's your mass in air? Now you have to be very careful. They've given you the mass of the container. The bottle is what? 15.2 gram. Are you getting it now? So they now said when filled with kerosene, it is what? 24.8. So that means the mass of the kerosene is what? 24.8 minus the mass of the what? Container minus 15.2. This will give you what? 9.6 gram. Are you getting the logic? Then 27.2 gram when filled with water. So that means the mass of water is what? 27.2 minus the mass of that container minus 15.2. That's what? 12.0 gram. So slot it into your formula now. What's the relative density? They said the relative density is, yes, what's the mass in air? Okay, yes, so let's move on now. Now, you know, the formula for relative density of liquid is what? Mass of an object in the upthrust of an object in that liquid over the upthrust of an object in water. Now, in this case, you don't have any what? You don't have any object. They are not immersing any object in kerosene. They are not immersing any object in water. So what do you just do? The formula will change. It will just be the mass of the kerosene over the what? The mass of water. So that will give you the what? The relative density. So that's what? 9.6 over 12. So it's as simple as that. Why do we do it this way? Because no object was immersed in kerosene and no object was immersed in water. Yes, so it's as simple as that. So let's just 9.6 over 12 will give us what? This will be 12 in 96 8. So this is what? 0.8. 0.8. Yeah, let me check it. That's option D. That's option D. Yes, that's JAM 1994. Let me go to another question. Please don't forget the moral that I bring out of here. Yes, I said when you aren't given, when an object is not immersed in a liquid, they don't say an object is immersed anyway. So it will just be what? Mass of kerosene over mass of water. You can just call it zero. This one is zero. No, nothing was immersed. So you have 0 minus m of kerosene over 0 of minus m of water. 0 minus m of kerosene, that's what? Minus m kero. This one is also what? Minus m water. So minus we cancel m. So that's how we got this formula. Do you get it now? Let's move on now. Another question. Yes, I'm seeing a question here now. Please, I'm coming. Yes, 1995. A body weighing 10 Newton. A body weighing 10 Newton. Weighing 10 Newton in air is partially immersed in water. It displaces water of mass 0.3 kilogram. They said, what's the upthrust? What's the upthrust? Yes, let's go now. What's the formula for upthrust normally? Upthrust is what? Weight in air minus weight in that liquid. Yeah. Yes, so they said it weighs 10 Newton in air. Then it displaces water of mass 0.3 kilogram. So the weight in water is what? Weight in that liquid is 0.3 kilogram. So just convert this one to what? To Newton. That will be what? 0.3 times 10. So your upthrust is what? Weight in air 10 Newton minus weight in liquid 0.3 times 10. That's 3. 10 minus 3. That's 7 Newton. Yeah. Let's move on. Yes, that's the answer. Let's skip to the next one. So another question here. A question on relative density. So please try this one on your own. Once I'm done writing the question, just pause it and try it. An object weighs 2.7 Newton in air and 1.2 Newton when completely immersed in water. Calculate its relative density. What are you calculating here? Relative density of a solid, an object. They are not talking of a liquid here. Let me remind you, what's the formula for the relative density of a solid? That's what? Weight in air over what? Weight in air minus weight in water. Okay, try it now. Just pause it and try it out. I'm sure you've done that now. So yes, never forget the formula for the relative density of a solid. Weight in air over weight in air minus weight in water. That of a liquid is what? Weight in air minus weight in liquid over weight in air minus weight in water. Let's move on now. What's the relative density of a solid? That's what we are calculating. What's the weight in air? 2.7. What's the weight in air? 2.7 minus. What's weight in water? 1.2. So you have 2.7 over 1.5. That will give you what? 1.80. So that's the relative density. That's the relative density. Yes, let me pick another past question. I just want to solve a whole lot of questions so that we have enough confidence that is well grounded before we move to the more advanced. Like after this one, we have just one last case, and that's over for density. It's just very simple. Let's move on. Yes, we have a question here. Yes, please, I'm coming. A piece of metal of relative density 5.0 weighs 60 Newton in air. Calculate its weight when fully immersed in water. Yeah, let's solve it now. So we have metal is what? Is solid. So relative density of solid is equals to, what's the formula? You can pause this one and try it out. Pause it and try it out. I'm sure you've done that now. Let's move on. Relative density of solid is what? Weight in air over weight in air minus weight in water. What's relative density? 5.0. What's weight in air? 60 Newton. Over weight in air 60 minus what's weight in water? That's what you are calculating. Calculate his weight when fully immersed in water. So cross multiply 5 into bracket 60 minus weight in water is equals to 60. So this 5 will cancel this 60, 12. 60 minus weight in water is equals to what? 12. Well, don't worry, you can open the bracket if you are confused on how I got it. But that's simple. So you have 60 minus what? Minus 12 is equals to weight in water. Weight in water is equals to what? 48 48 what? 48 Newton. So yes, that's our answer for that. Yes. Let me just take two more questions. Yes, a solid weighs, you are the one trying this one. A solid weighs 45 Newton and 15 Newton. This was 2002, respectively, in air and water. Determine the relative density of the what? Of the solid. Determine the relative density of the solid. Yes, let's solve it now. So what's the formula for relative density? Relative density is equals to what? Is equals to, now this is a solid, weight in air over weight in air minus what? Weight in water. So they said you should find the relative density of the solid. I believe it's simple. Can you try it out? Yes, just pause the video, try it out. Let's take it together now. We are finding the relative density. What's the weight in air? 45 over weight in air 45 minus weight in water 15. 45 over 45 minus 15, 30. That's what? 1.5. Hope you get it now. Yes, according to my promise, let me just take one last question on this case before I move on to the next. Yes, what's the question? Okay, yes, I have a question from 2004. An object weighs 60 Newton in air, then 48.2 Newton in a liquid X, and 44.9 Newton in water. Calculate the RD, the relative density of what? Of X. What's the formula for relative density? Now this is what? An object. An object. So you have what? Okay, they said in a liquid X, then they said calculate the relative density of X. X is a liquid in a liquid X. So what's the formula for relative density of liquid? That's what? Weight in air minus weight in liquid over weight in air minus weight in water. What's weight in air? 60 Newton. What's weight in liquid? 48.2. What's weight in air? 60 Newton. What's weight in water? 44.9 Newton. 60 minus 48.2 will give you what? 11.8. Are you following? 60 minus 44.9 will give you what? 15.1. So just divide 11.8 divided by 15.1. That will give you what? 0.782. That's my answer. Up to this level, are you parents confused? It is very, very simple. Very, very, very simple. Yes, let's take the last case on this now. Yeah. So you have upthrust. When we started, I said upthrust is the same thing as what? The volume or the weight of fluid displaced. I proved this formula at the beginning. Then I told you that weight of fluid displaced is the same thing as what? Mass times G. The mass is what? Rho Vg. And I remember telling you that this density is for the what? Is for the liquid. This volume is for the what? Object. Now for this for the object, if half of the object is immersed in water, the volume will be what? 1/2 times the volume. If 1/3 of the object is immersed in water, it will be what? 1/3 times the volume. Are you getting it now? So yes, that's just it. Density of liquid times volume of object times acceleration due to gravity. Let's take our let's take questions on this now. Yes, so it's very, very simple. So this is the last case on this. Then we move on. Yeah. So let's take this question. They said, please, I'm coming. A block of material, this is 1993, is about a block of material or volume 2 times 10 raised to power minus 5 meter cube and density 2.5 times 10 raised to power 3 kilogram per meter cube is suspended from a spring balance. Don't mind me. With half the volume. Can you see what I'm saying? That will be what? 1/2. With half the volume of the block immersed in water. They said, what is the reading of the spring balance? If they say what's the reading of the spring balance, that means what will be the weight of that object in what? In water. What will the spring balance read while it is in water? So you are looking for weight in water. Yes, what's the formula for upthrust? Upthrust is what? Rho Vg. And don't forget that upthrust is also the same thing as what? Weight in air minus what? Weight in that liquid. This liquid is water now. So we can say yes. Let's solve it now. So yes, the they gave you the density of that liquid. What's the density of water? 1000 kilogram per meter cube. So let's solve it now. What's the weight in air? Let's calculate the weight. They did not give us the weight in air, but we can get the mass of that block. How do you get the mass? Mass is equals to what? Density times volume, right? Mass is density times volume. So they've given you the volume and the density of that block. So mass is what? Density 2.5 times 10 raised to power 3. Volume is what? 2 times 10 raised to power 5. Please, if you are confused, just play back and try to get it before you move on. Yes, 2 times 10 raised to power minus 5. So multiply it. That will give you what? 5 times 10 raised to power minus 2 kilogram. So the mass is what? 5 times 10 raised to power minus 2 kilogram. So if they ask you to find the weight, what of the weight? Weight will be what? Times 10. So that's 5 times 10 raised to power minus 1 Newton. Because weight is what? Mg. So slot it into your formula. What's the weight in air? 5 times 10 raised to power minus 1 minus weight in water. That's what you are looking for. Is equals to. So what's your density of liquid? That's what? 1000. What's the volume of your object? Volume of object is what? 2 times 10 raised to power minus 5. 2 times 10 raised. But they said the half of it. So it will be what? 2 times 10 raised to power minus half times half. 2 times 10 raised to power minus 5 times half. Times what? What's your G? 10. So just keep cutting. This cancels this. 5 times 10 raised to power minus 1. That's what? 0.5. Minus what's your weight in water? Yeah. Is equals to 100 times 10 raised to power minus 5 times 10 raised to power times 10. That's what? 10 raised to power minus 1. So 0.5 minus weight in water is equals to 0.1. So weight in water is 0.5 minus 0.1. That's what? 0.4 Newton. So it's as simple as that. So just know the formula very well. You know how to get your volume, your mass, and every other thing will fall in place. So yes, we have another question now. So just be calm. It's not hard. Yeah, 1997. A solid plastic cube of side 0.2 meter is submerged in a liquid of density 0.8 kilogram per meter cube. Then they said calculate the upthrust. Can you see? It's just too simple. What's this? Calculate the upthrust on the cube, on the liquid of the cube, Yeah. So your G is what? 10 meter per second square. What's the formula for your upthrust? Upthrust is what? Rho Vg. What's density of what? Your liquid, volume of your object, and G. Yes, get it from here. What's the density of your liquid? Density of in a liquid of density 0.8. So upthrust density of liquid 0.8 times volume. What's the volume of your object? They gave you the size to be 0.2 meter, and this is a cube. What's the volume of a cube? L cube. Volume of a cube is what? L cube. So L raised to power 3. So yes, what's your L? 0.2. So volume is what? 0.2 raised to power 3. That's the volume of a cube. Times what's G? 10. So it's as simple as that. 0.8 times 0.2 times 0.2 times 0.2 times 10. That's the same thing as what? 64. I'm coming. Let me try to see if I can do it offhand. 2 times 2 times 2, that's what? 8 times 8, 64. This 10 cancels this 0.64 times 10 is to power minus 3. That's 6.4 times 10 is to power minus 2 Newton. 0.064 Newton. It's as simple as that. Yeah. Should we take another one now? Can you see? It's very, very simple. Just very, very simple. Next question. A block of material of volume 20 centimeter cube and density 2.5 gram per centimeter cube is suspended from a spring balance with half of the volume. Take note of that. Half of the volume immersed in water. Half of the volume of the block immersed in water. Then they said, what's the reading of the spring balance? What did I tell you is the reading of the spring balance? What that block will weigh inside the water. What's the reading of the spring balance? So that's what's the weight in water. Weight in water. Yeah, let's solve it now. They've given you the density, they've given you the volume of the material, then they said half of it, then is immersed in water. What's the acceleration due to gravity? What's the density of water? This is gram per centimeter cube. So the density of water you use will also be what? Will be in 1 gram per centimeter cube. So yes, let's solve it now. Let's solve it now. So weight, upthrust is the same, is what? Density times volume times acceleration due to gravity. And upthrust, because you are dealing with the reading of spring balance, the weight in water, you say upthrust is the same thing as what? Weight in air minus weight in water is equals to density of the liquid. Density of the liquid times volume of the object times acceleration due to gravity. What's the weight in air? How do you calculate it? You are not given. So calculate it from your what? From your mass. So get your mass. Get your mass. Mass is what? Density times volume. What's your density? 2.5 gram per centimeter cube. What's your volume? 20. Multiply it. That's what? 50 gram. Do you get it now? Now they said you should find your what? Weight. What's your weight? Divide by 1000. So this will give you your kilogram. Then times 10. I don't know if you get what I did. You get 50 gram, right? Now you want to get your weight. Weight is what? Mass over this gram. Change it to kilogram by dividing by 1000. Then change it to weight by multiplying by 10. So this is just what? 0.5 Newton. So yes, weight in here 0.5, or we can even leave our answer in gram. Can leave our answer in gram. Anyone. Yes, let me just leave my answer in gram. If I want to leave my answer in gram, I may not bother myself. Weight in here is what? I can say weight in here is what? Mass in here times acceleration due to gravity, right? Minus mass in water times acceleration due to gravity. So I can put it in brackets together. I hope this will not get you confused, but it's just the normal method. Yes, just writing what I have before. So this G can actually cancel this G. So your answer will just be in mass straight. You are not converting to weight and all of that. So yes, what's your mass in air? 50 gram. What's your mass in water? That's what you are looking for. The reading of the spring balance is equals to, what's the density of the liquid? Water, 1. What's the volume of the liquid? 20. Do you get it now? So what's 1 times 20? That's 20. So mass in water is equals to what? 50 minus 20. That's what? 30 gram. So if your option now, oh, I think there's a mistake here. They said half of the volume. Sorry for that. Half of the volume. So it should actually be volume times 1/2. Please, I'm very sorry for that. My ass skipped it. So this should be 2 in 20, 10. So this should be 10. So 50 minus 10 is what? 40 gram. So when I check the options that I see that, oh, we forgot something. Yes, so this is what? 40 gram. 40 gram. So that's your answer. 40 gram. 40 gram. So you can just play back and try to watch it again You've not gotten it well. Yes, let's take some other questions now. How many questions should I take more on this? This is the last case. Yeah, let me take 5 more. So we treat 5 questions more together. Then you go over your series and the theoretical aspect too, because this is actually dealing with the calculation aspects alone majorly. Yeah, but there is nothing really much in the theoretical aspect truly. Yes, let's move on now. Another question. Yes, we have 1992. A solid weighs 0.04 Newton in air and 0.024 Newton when immersed in a liquid of density 800 kilogram per meter cube. They now said, what is the volume of the solid? This is very simple. What's the volume of the solid? Yeah, let's solve it now. They've given you the weight in air, right? They've given you the weight in that liquid. So your upthrust is ready. Upthrust is weight in air minus weight in liquid. Then you know that upthrust is also equals to what? Weight in air minus weight in liquid is equals to what? Rho Vg. Density of the liquid times volume of the object times acceleration due to gravity. They've given you the density of the liquid. This is it. They've given you, so they said you should find the volume of the object. So I think you should be able to try it out. Yeah, let me give you a minute. Yes, just try it out. Just pause it, then resume it again. I'm sure you've done it now. Yes, what's the weight in air? 0.04. What's the weight in liquid? 0.024. What's the density of liquid? 800. We are looking for the volume of object times 10. This is what? 0.016 is equals to 800 times V naught times 10. So you divide both sides by this 8,000. So yes, V naught is what? So if you try to divide, that will give you what? 2. That's 2 times 10 raised to the power minus 6 meter cube. Yeah, you can press it in your calculator, you get the same thing. So yes, that's the answer to that. 4 more questions to go. Yes, let's take another one now. 2000. The apparent weight of a body when immersed in water is 32 Newton and its weight in air is 96 Newton. Calculate the volume of the body. They gave you the density of water to be 1000 kilogram per meter cube. Then acceleration due to gravity to be what? To be 10. Yeah, let's move on now. The apparent weight of a body when immersed in water is what? 32 Newton. So weight in water, 32 Newton. Weight in air is what? 96 Newton. They said calculate the volume of the body. You should get this. You should get this. So yes, that's what weight in air minus weight in water is equals to what? Density of liquid times volume of object times acceleration due to gravity. I believe you can get your answer from here. Yes, so try it out, pause, and let's resume. Let's move on now. I'm sure you've gotten it. Weight in air is what? 96 minus weight in water is what? 32. Density of the liquid is what? Water, 1000 times volume of the object times acceleration due to gravity, 10. So 92 minus 32, that's what? That's 64 is equals to 10,000 V naught. Divide both side by 10,000. V naught is what? 6.4 times 10 raised to the power minus 3 meter cube. I hope you get it now. Yeah. Oh yeah, so according to my promise, let me take 3 more questions. 3 more questions now. Yes. Oh, this next question is very funny. I will give it to you, and I'm sure you are probably going to miss it. Not because you don't know it, but because you will not be calm. Can we try it out? Yeah. Yes, so 2001, an object of weight 10 Newton immersed in a liquid displaces a quantity of the liquid if the liquid displaced weighs 6 Newton, determine the upthrust of the body. Yeah. So let me ask you, what's the answer? What's the answer? What's the answer? Yeah. Yes, I'm sure you will miss it. Yes, let me see if my guess is right. They said if the liquid displaced weighs 6 Newton, what the Archimedes principle says, he said it experiences an upthrust which is equals to the what? The weight of liquid displaced. So you are not subtracting anything. They've given you already 6 Newton. They are not telling you that the weight in the liquid is 6 Newton. They are not telling you that the weight in here is 6 Newton. They said the weight of the liquid displaced is what? 6 Newton. So that's just to answer straight. Do you understand? They did not tell you that the weight in water. They said the weight of the fluid displaced is what? 6 Newton. That's the upthrust. Do you get it now? Yes, so it's as simple as that. Okay, which other thing can I talk on? Okay, I have 2 more questions to go. Now, be wary of this type of question. Read your questions very well so that you don't fall into traps. Note when they tell you that, oh, it weighs this in water. But if they said, then you know that I've not seen this type of questions through the series, but they can actually ask because yes, they can twist questions anyhow. You know that upthrust is what? Upthrust is rho VG, right? Now they can give questions like this. Upthrust depends on 2 things: the density of the liquid, not the density of the solid. I've always repeated it. Density of the liquid and what? Volume of the object. I don't want to go to the theoretical aspect. Let me just focus. Okay, yes, let me just give you. So it focus on what? So upthrust is directly proportional to the what? Volume of the object. So yes, please take note of that. And relative density is inversely proportional to the volume of the object. You know, relative density is what? Is upthrust of upthrust. Relative density of a solid now, for instance, relative density of a solid is upthrust in liquid or weight in air over weight in air minus weight in liquid. That's what upthrust, right? So relative density of a solid is equals to weight in air. What's upthrust? Rho Vg. Yeah. So relative density and the volume of objects, they are what? They are inversely proportional. I've seen theoretical questions where they try to miss that. They are what? Inversely proportional. Inversely proportional. Yes. And even the formula for your relative density of liquid can even be relative density of liquid can be, you know, here you have for liquid it will be what? Upthrust in liquid over upthrust in water. So you can also say volume of fluid displaced, volume of liquid displaced by object. I gave you this formula in the beginning, over volume of liquid displaced by water. So you can see questions like that. I don't know why I'm not meeting those types of questions, but yes, theoretical aspect they can try to mix anything. Just read it up or practice questions, but I'm sure I've talked all the calculation aspect. So yes, let me just fulfill my promise. I said I will solve. Yes, so I have 2 more questions to go. Yes, let me just pick yes, this very question. This question is just too simple. Yes, so let's just, okay, I said 2 more questions to go. Let me just search randomly for questions. I'm coming. I want to give you questions that will twist your brain so that you aren't. Yes, I'm coming. I have a question here. Yes, this one is too simple. Yes, let's take this one. This is a mental trap. I guess you'll fall into it again. Just be careful. A piece of stone weighs 180 Newton in air and 150 Newton in a beaker containing 160 Newton of methylated spirit. What is the upthrust? Yeah, this is a perfect question. Yes, it's very simple, but many people will fail it. Yes, can you try it out first? Okay, yes, what's the formula for upthrust? Weight in air minus weight in the liquid. What's the weight in air? 180 Newton, right? What's the weight in the liquid? Is it 150 or 160? Now, this is, he said A piece of stone weighs 180 newton in air and 150 newton. So the weight in the liquid is what? 150 newton, not this 160. This 160 is referring to the what? To the weight of your methylated spirit, not the weight of that stone. You understand? So weight in that liquid, the weight of the stone in that liquid is what? 150. So the upthrust is what? 30 newton. Some people will go for 20 because they will say their weight in liquid is 160, which is wrong. Yes, please take note of this type of questions. One last question. Please, you give me some minutes to get. Well, yes, a special type of question. Okay, I'm coming. Very good. I have a question there. A block of volume. This is actually a wide question though, but yes, just try it. 3 times 10 raised to the power minus 5 meter cube and density 2.5 times 10 raised to the power 3 kilogram per meter cube is suspended from a spring balance with 2/3 of its volume immersed in the liquid, immersed in a liquid of density 900 kilogram per meter cube. So they said determine the reading of the spring balance. Yes, that's what your weight in water or your weight in that liquid of spring balance. So weight in that liquid, that's what you're looking for. What's the formula? Formula for upthrust: weight in air minus weight in that liquid is equals to what? Density of the liquid times volume of object times G. Right? Yes. So this is a very interesting question. Volume is what? 2/3 is mass. So you get your mass. You can get your mass and your weight from here. So let's get the mass. Mass is what? Rho V, density times volume. What's your density? 2.5 times 10 raised to the power 3. What's your volume? 3 times 10 raised to the power minus 5. We want to get our weight first. So we have, we multiply it, you have 7.5 times 10 raised to the power minus 2 kilogram. So yes, what will be the weight? Weight, if this is the mass, the weight will be what? Mg. So times 10, this is what? 7.5 times 10 raised to the power minus 1 newton. So yes, what's your weight in air? Weight in air is what? 7.5 times 10 raised to the power minus 1 minus what's your weight in liquid? That's what you are looking for. Determine the weight of the spring balance. Yeah, the reading. Yes, what's the density of your liquid? They've given you 900. That's what's the volume of your object? 2/3 of what's the volume? The volume is what? 3 times 10 raised to the power minus 5 times G 10. So it's as simple as that. As complex as it seems, it's as simple as that. Yes, let's solve it. So 7.5 times 10 raised to the power minus 1 is what? 0.75 minus weight in liquid. Multiply this, you get what? You get I'm coming 18. I'm trying to do it here. 18 times 10 raised to the power minus 2. So you have 0.75 minus weight in liquid. This will give you what? 0.18. Collect like times 0.75 minus 0.18 is equals to what? Weight in liquid. So weight in liquid is equals to what? 0.57 Newton. So it's as simple as that. This has brought us to the end. Yes, I will advise you watch, you try the questions again, or yes, if you've gotten it, if you've been getting all the questions I ask you to try, then perfect, that's a good job. Thanks so much for staying through to the end. This is the end of Hydrostatics. Yes, this is the celebrated Achievers Mentorship Program. Don't forget to like, share, and subscribe to this YouTube channel and click on the notification button to get updates of other videos that will be uploading soon. Yes, if you enjoyed this video, please give us a very beautiful comment in the comment box. We love you. We wish you massive success.